Hey guys, welcome to this session by Intellipaat. So Hadoop is highly scalable in nature. It helps organizations to run applications from a huge number of nodes that could involve thousands of terabytes of data. And the best way to understand the scalable nature of Hadoop is to work on a hands-on project. So today we have come for this session on Hadoop project where you learn how to implement a multi-node cluster. So before we go ahead and start our class, do subscribe to our channel so that you get a notification of our next video. And also at the end of the class, there'll be a quiz to recap what we've learned in today's session. So do put down your answers to know if you've answered correctly. And also you can put down all of your queries. We'd love to help you out. So without much delay, let's start off with the class.
Now for this, I will buy server which is 6.3, CentOS 6.3 in West Coast. I wanted something that has decent RAM, so I'll go for 4 gigs of RAM. I think that's fair. Going for 8 would be too high, so I think 4 would be what I'm looking at. I'll go with the default security group, and this is my key value pair which is named Ravi, and I say bank. So my first machine is started. So while this machine gets started, let me buy another machine. I need 3 machines, right? So I say, by the way, guys, I would request everyone to please open the PDF, and I'm doing exercise number 7. All right. So Oregon. Then I say I want a medium machine. Repair, and I say bank. Machine number 2 is firing up, and I'll go buy third machine again. CentOS. So this Oregon. All good, and I say all the 3 machines are successfully purchased. When I refresh, you will see a couple of them started, one of them starting. So one of them has started. I'll rename that as Mr. Name Node. All good. We'll soon have our other machine also getting started. Here you go. That's machine number 2. I call this as data node 1. Cool. Then I soon have third machines that will be starting. And that is my data node 3. Data node 2. Sorry. So these are 3 machines, all purchased, all done. We are good. Now, one quick question. So now you are running your computers, all good, all great. Now it's time for us to connect. Now I want to connect to my name node. So I say, Mr. Name node, I want to connect to you. So I say connect. What I do is I directly take the command which will be connecting to my machine, and I'll say copy, open it in terminal, and say connect. So you see, I'm logged in my first Amazon machine. All great. So I'm already logged in as root in this machine. All good. I want to connect to my second machine. Connect. I say, please help me connecting to my second machine. So I say, open a new shell window. And I say, please help me connect. Say yes. So I am in my second machine now. Now let's go and connect to my third machine. I say connect, get the command here. I say All right. Awesome. So I'm connected to my name node, data node 1 and data node 2. Now what you see is, well, this is my name node, this is my data node 2, and just lost sight of my data node 1, that is now I have 3 machines, and this is my name node.
Right guys, so just a quick info. If you're interested in doing an end-to-end certification course in Hadoop, then Intellipaat provides the Big Data Hadoop certification course where you learn all the major concepts of big data, such as mapreduce, Hive, Pig, Scoop, Oozie and Flume. So this training will build up your skill set and make you industry ready. So without much delay, let's go on with the class.
Last question. Yes, Amrish, everything is uploaded. Everything is uploaded, Amrish. So, do you guys see one problem here that I'll have to remember IP addresses of all the machines, which is not a good idea. Not at all a good idea. So, let's change them to more meaningful names. So, what I do is I say, this is my IP address. I say vi etc sysconfig network. And I say I want my host name to be name node. So I say my host name is name node. All good. Then I say vi etc host. And I say whenever somebody talks to you about IP address this, please translate it to name node. Similar here. So my name node is done. Then I have to look for what is data node 1 and what is data node 2. This is my data node 1. So my data node is my name node. So 10 dot. So this is my data node 1. So what I do is I say vi etc sysconfig network. I say this is my data node 1. And say I have config take this and I say vi etc host. What I do is I say data node 1. This should have been data node 1, right? All good. Now we go to machine number. So this is my data node 2. So I say vi etc sysconfig network. And I say I want my machine to be named as data node 2. All good. So I'm done with my data node 1 and I'm done with my data node 2. I need to take the IF config for this machine. take this up, copy vi etc paste, and I say data node. Now let's see the magic. I have basically changed host names of all three. All I will do is I'll reboot all of them now. I'll restart all of them so that after this there are no confusions whatsoever. So I have shut down all of them and restarted all of them. Yes, it is possible, Arjun. You can very well. There is a browser client also. Instead of using putty, you can use a browser client. Amazon has that. All right, so all three machines have started. Now you see something interesting here. Okay, let's go one by one. This is my first machine. I just say connect me to this. What do you see here? You see name node. I do the same thing here. And this guy tells you welcome to data node 1. I do same thing here. And this guy tells you welcome to data node number 2. So we all are done with the pain of basically remembering IP addresses now. All good? So now this is Mr. Name Node.
Right guys, so just a quick info. If you're interested in doing an end-to-end certification course in Hadoop, then Intellipaat provides the Big Data Hadoop certification course where you learn all the major concepts of big data, such as mapreduce, Hive, Pig, Scoop, Oozie, and Flume. So this training will build up your skill set and make you industry ready. So without much delay, let's go on with the class.
Mr. Data Node 1. We don't have to again remember their IPs or something. And this is Mr. Data Node number 2. Now I'll wait for a minute and request everyone to confirm. Now let me tell you the steps. What we will do is session notes. First, we have purchased blank machines with absolutely nothing on them. So here are the steps. Install Java, install Hadoop, and run exercise number 7. So is this clear, guys? See, we bought machines which are absolutely blank, absolutely nothing on them. All right. And what we are doing right now is so my step 1 is install Java on the virtual machines. These are blank machines with only operating system on them. And this recording will also serve you ahead in basically at your workplace, because you will know what to do exactly from ground zero. Just okay. So these are blank machines, and you will be seeing we'll first install Java. Then we will install Hadoop. And then we will install we will set up multi-node cluster. These are simple 3 steps. So let's get started. So my step 1 is install Java, where my first command is yum install wget. Yum install wget would basically, it's a utility that will let me download stuff from internet on my Linux box through command line. So it is yum install wget. So I'm doing nothing, just installing a package on the from on Linux box, nothing else, no rocket science. So wget is installed. Now I'm downloading Java. So I'm doing nothing, just downloading Java from the internet, nothing else. Just downloading Java from the internet. Java is getting downloaded from the internet, nothing else. Now, when you install Java, there are certain files that are of not useful to us and they are not present. So Java may complain, but that's okay. You have to ignore those warnings and go on with the installation. You say, I am again doing nothing, just installing Java, nothing else. So now Mr. Java is installed. This is done right now and I am pasting the commands for you guys. All right. So my step number one, downloading and installing Java is 100% done. Step number one is done. Let's talk about step two. We'll just set up the download for Hadoop. So we are setting up a Cloudera repository. So we are right now installing a Cloudera repository. Okay, and we will install Hadoop right now in a minute. You will see that. Now comes the most important step. We have just set up Cloudera repository. Now we will install Hadoop. So we've just run a command and everything is happening automatically. So just run the command and you'll be done. So Hadoop is getting installed, looks like some Matrix movie, all those things are going up and down, up and down, up and down. You are installing it on 3 machines together. So this is on Amazon US server, that's why it's still taking less time. If you do this typically in India, it may take 2 hours. That is why if you see, the virtual machine has already Hadoop installed for you guys. So Hadoop is 100% installed. All right. Now there are two most important questions. Correct. So very simple. Type Java on command prompt and you'll come to know whether Java is installed or not. So this says Java is installed. If not, it would have said command not found. Correct. So that means Java is there. That's why you see this. Okay. So hope this is clear, that how do you verify if Java is installed? This is how you just go about. Man, why is it this opening every now and then? And here also it's the same. All good. Now let's move to the next question. Yes, there are other ways. Just say Java version. Sorry. So this tells you what Java version is installed. All right. So this answers your question of how do you verify if Java is set up. Now let's talk about the next question. No, you don't need to. Once you install, it's already set up for you. All right. So that is how you verify if Java is installed. Now, next very important question is, what exactly is Cloudera Repository? Let me give you a small introduction to that, a minute introduction to that. Okay, not required here. Let's put it simply. In Windows, agree? All right. Now, in Unix or Linux world, you mostly So in a nutshell, it is nothing more than a directory or a repository service where or an address service where. Oh, sure. I'll explain this. Yeah. In Windows world, you download something that is exe or MSI and double click uh, and everything gets installed. In Linux world, you mostly install stuff from command line. Now, I'm not getting into details of it as to how exactly it works, but it's this. When you order the operating system that, hey, I want to install this particular software, the operating system goes to list of repositories and checks if this software is available with them. The repository basically just has the URL or address of where this installer can be found on the internet. And what really happens is when you say yum install Hadoop, it would go to the repository and say, do you know somebody called Hadoop? And typically you will not find an answer. They will say, we don't know who's Hadoop. But then if you set up Cloudera repository, Cloudera will know where is Hadoop. So then your operating system finds that and it basically downloads and installs that for you. So it's more like a reference structure where from your command line, the control goes to the repository locations and repositories will tell you whether they have this software or not. All right. So, yippee, step 2 is done. Now, is everything clear and is it making sense? Just to, if you want to verify if Hadoop is installed properly or not, all you need to do is say rpmql Hadoop 0.20 conf sudo. This tells you that yes, Hadoop is installed and this is the configuration of Hadoop. Now, this is already there in exercise number 2, step number 2. And it's clearly written that this is how you verify if Hadoop is installed or not. So that's kind of already there, yeah.
Right, guys, so just a quick info. If you're interested in doing an end-to-end certification course in Hadoop, then Intellipaat provides the Big Data Hadoop certification course where you learn all the major concepts of big data, such as mapreduce, Hive, Pig, Scoop, Oozie, and Flume. So this training will build up your skill set and make you industry ready. So without much delay, let's go on with the class.
So guys, this is an important logical step. And now we go to step 3, setting up multi-node cluster. Please have your PDFs open and be on exercise 7. All right. Now it's time for us to get started with the setup part. So Hadoop is installed and we are all set. Can you please open PDF and please go to exercise number 7? And I'm talking about step 2. So we've just installed Hadoop. We need not stop services because we haven't started any. Please go to step number 2 and I want to explain a few things. All right. I guess everybody is on step 2. Now I have one question. So let's understand what is alternatives. So guys, if you really go deep, what you see is every software has two things. You'll have many things, but there is the code, and the code basically runs on or points to certain configuration. So now, do we all agree that typically every software has some code and it points to certain configuration? Agree? All right. Now, this I would say is your software that has code and certainly follows certain configuration. Now, Mr. Alternatives framework lets you have multiple configurations and lets you point to any of them at a given point of time. Straight, nothing else. Mr. Alternatives framework is basically, it lets you have multiple configurations and lets you basically point to any one of them. What I mean to say is, you can very well have configuration number 1 and you can very well have configuration number 2. Okay, configuration, my configuration. Now point to this, I can do that. I can point to this, I can do that. I can again point to this, I can do that. If my mind changes, I point to this and I just play. And this is possible through alternatives framework. Now let me show this to you and you tell me what do you make out of this. Okay, look at this carefully and tell me what is that you're understanding out of it. Tell me what do you make out of this. This tells you that Hadoop has two configurations on this machine. It has two configurations on this machine. As of this very moment, conf.sudo.mr1 is the one which has higher priority, and as of this very moment, Hadoop is pointing to etc Hadoop conf.sudo.mr1. If there are two configurations, one is empty, other is the other one, because it has highest priority right now, Hadoop is pointing to. So current best version for Hadoop configuration is etc Hadoop conf sudo mr1. Does it make sense? Let's understand the concept. Everything else is just running a Linux command. It is matter of just, it's a cakewalk once you understand the concept. So just focus on the concept. Concept is this: one software can run on multiple configurations, and with alternatives framework facility, you can have them and you can point to any configuration. And the priority is based on your wish. What you decide is the priority. Now you will see that in 1 minute. Okay, you will see that in a minute. So you see, what I do now is, using an empty template of configurations, I am creating a new configuration. So what I say is, let's say sudo cp-r etc hadoop conf.empty. Conf.empty is just a template, nothing else. Copy that to etc hadoop conf, let's say conf.distributed. So I'm creating a new configuration called conf.distributed. As of this very moment, conf.distributed is empty. It is empty because I'm just copying a template. That's it, nothing else. It's conf.distributed. Now just focus on what I'm doing and you'll realize the whole thing. Now tell me, what do you see? Now, does it make sense? All I have done is I have created a new configuration which is as of this very moment empty. That's okay. And I have set a priority which is 99. And because I have the highest priority, my configuration is what Hadoop will run with. Is that clear? Awesome. Now let's do that on all three because we want our configuration to be a distributed configuration as highest priority. What we do is we say then just to verify if all has gone well, what you see is you see that our configuration gets the biggest priority. So now we are done. Now our Hadoop is pointing to the configuration of our choice, but our configuration of our choice is empty. So we will now fill the configuration. But before that, the most important point is, you know what? It's a cluster. Cluster means the machines should be able to talk to each other and they should know each other. But do they know each other? Let's see. If I say ping data node 1, this guy says I don't even know data node 1. Yeah, we are in same Amazon network. We may know each other by IP, but we don't know each other by name. That's a problem. So let's first make sure that everybody knows each other by name. So I want to stop here and say as of this moment, our Hadoop is pointing to config of our choice. Okay. Yeah. So far, config of our choice is empty. Got it? All good? Exactly. So now after our config is correct, let's now make sure that the machines know each other by name. So simply putting it, what we'll do is I'll take ifconfig, which is this. I go and say vi etc host, and I'll say whenever I talk about data node 1, please translate it to this IP. Okay. And whenever I talk to you about data node 2, please translate to this IP. So now everybody knows everyone else. Now that they know each other, but we have to first also see, are they able to ping each other? So I say ping node 1. Now it is able to translate who it is, but it is still not able to ping it. Correct? It is able to translate. Now it knows that whenever data node 1 is there, I am talking about this IP. Okay, but it's not still not able to talk to it. So let's make sure that they talk each other on ping basically. So let's first copy these three values across the network so that I go say VT VI etc host. Okay, so that brings us to now they are still not pinging each other because the firewall doesn't allow them. So let's make sure that the firewall allows them. So if you see, let's see what security group they fall into. So when you see all three machines, they follow the default, which is 2012-79. So this is my security group. So I'll show you the security group. So all of them, they belong to this firewall rules. What I say is, please allow all ICMP. All ICMP ping works on ICMP protocol. I'm just adding a firewall rule and it has nothing to do with Hadoop whatsoever. Okay. All I'm saying is all ICMP communication should be enabled. This is a networking thing. Now I say, can you ping data node 1? It says surely I can ping it because ICMP is on now. Then I ask it, can you ping data node 2? Says fantastic, I'll do it. Does it? Say ping name node. Can you do that? Or name node, my spelling is wrong. It says 100%. I can talk to name node. I ask him, can you talk to name node? It says sure, I can. All right. So now, as of this moment, everyone knows each other by name. All right. Can you look at the PDF and I'm just following the PDF? You would see that our step 5 is now 100% done. So now if you see, everything is documented and we are done till exercise 7. Step number 5 is 100% done. Now exercise 7 step 5 is 100% done. Okay, now my machines are talking. My cluster or my whole cluster is now pointing to the right configurations. So far my configurations is empty, but okay, we all agree that my configurations are empty. We haven't done anything to the configuration. Agree? Our configurations are empty. Is everybody in sync with me? We've just taken a template of an empty configuration. I haven't done anything in the configuration whatsoever. All right. Now it's time to change the configurations. Okay. So if you see, I will explain you all the configurations. Don't worry about it. If you see, Hadoop typically has all its configs in XML and they are placed in etc Hadoop. Okay. So now let's modify those configs and let's So if you see, Hadoop has three most important configuration: HDFS, core site, and third one is MapRed, which we'll create right now. Okay. Once we have all these configurations ready, we can certainly go ahead and set up the cluster. As of this very moment, my cluster is pointing to conf.distributed, but that is empty. So now I will fill those configurations. Once I fill those configurations, we'll go ahead with the next setup. Now we can type all the configurations one by one, but for now I have them in XML and I will directly copy them. Okay. And then I will explain you each and every configuration. So I say vi core site.xml. Right now this is empty. I say so in this particular configuration, all I am saying is the name of the configuration is fs default name. All I am trying to convey in this configuration is the name node of this cluster. The master of this cluster is a computer called name node, and it works on port 8020. I'll do exactly the same thing here. I want to tell it that your manager is name node. All I'm saying is your name node or your manager is name node, which is this machine. And that is how it points to the master. cd etc hadoop conf vi core site.xml. So far what we've done is I have told all, so master needs to have its setting, but I have told both the guys, both the slaves, that he is the boss, he is the manager, nothing else. All right, now the next setting is vi hdfs site.xml. So first we'll do it on just remove the existing setting. What I'll do is I'll say hdfs site.xml. Okay, I'm sure everybody would need this XML files. Please don't worry. I'll pass them today with the session notes. Okay, so you'll have them. Please don't worry about it. They are all yours. So if you see, there are three properties that I'm setting. See, if you see, HDFS is operating on top of your Linux file system. Okay, HDFS is operating on top of your Linux file system. So what's happening is I am telling that the name node will store its data, the metadata. When it writes to disk, it will store it in a folder called home disk1 dfsnn and home disk1 dfsnn. In real world, there'll be two different volumes of the hard disk, or maybe two hard disks itself. Then I say the data node will write its data blocks in.
Right guys, so just a quick info. If you're interested in doing an end-to-end certification course in Hadoop, then Intellipaat provides the Big Data Hadoop certification course where you learn all the major concepts of big data, such as mapreduce, Hive, Pig, Scoop, Oozie and Flume. So this training will build up your skill set and make you industry ready. So without much delay, let's go on with the class.
Home disk1 DFS data node, home disk2 DFS data node. And the third thing I say is I want to access name node from port number 50070. These three are the configurations that I'm putting in the. Then I say go ahead, do the same thing here. All good. Okay. Now the last file that I need to take care is mapreduce. These are the three most important files. The parameters of HDFS site. All right. So the first parameter is DFS name dir. That means where exactly will my name node write its data on the hard disk. Okay. See, name node writes all its metadata in RAM, and after that it flushes it. Now it flushes it to the disk. So where exactly will it write? That's point number one. Okay. Then point number two is where will data node store the blocks on the disk? See, data node HDFS operates on top of Linux box. That means it will store something on the Linux drive only. Which folder will we allocate to data node? Home disk1 DFS DN, home disk2 DFS DN. And what is the web URL to access name node? This is my name node. And why am I having the data directory here? And this is my data node. Why am I having the name directory here? Because I'm not going to run name node here. The point is this: when you're talking about Hadoop, you're actually talking about a 50 node machine. And when you're talking about 50 node machine, you would not want to have different kind of setups on every machine. So just to maintain that standard, you put all the configurations everywhere and then choose which daemon or which Java processes will you start. So yes, on the name node data directory setting is not required. On the data node, name node directory setting is not required, but it is done from the standards perspective, just that it becomes easy for the administrator. Just a minute. All right. These disk1, disk2 that you see, these directories are going to be created by me after the configurations are done. I'll be creating them in the next step. Okay. So now HDFS site is done. HDFS site is done. And now we will talk about, we will do the mapred site, basically the mapreduce configurations. Let's do that. Mapred, text edit. I say, let me do mapred. What I do is I say vi mapred site dot xml, and I just, okay, I'll have to paste the whole file because we are creating this as new one. Oops, did I close that? My bad. Desktop, XML files, XML files. I'll just copy the whole thing, and then what I say is I say paste this. I'll explain you the mapred configs, no worries. All good. Now let's understand what is in. All right. Now the next important part is what exactly is in MapRed directories, MapRed site. If you see MapRed site, the first thing I say is who is the job tracker? The job tracker is running on the machine that is called name node and it is running on port 8021. Second, where will MapReduce write its intermediate data? It will write it in home, disk 1, MapRed, local. Third, what is the root directory for mapper? Basically, when you run a program, you are running it as, let's say, user training. So what is your current directory? It is slash user username. So that is what you are doing for what you call MapReduce. Now, once these three configurations are ready, in this configurations, we have committed that we will create some directories. Now it's time for us to do that. See, these are local directories. See, MapReduce will store its data somewhere, right? While it is processing, that is the local directory. Staging root directory is when you run a particular job, where exactly do you want that intermediate data to store in staging? It will be in slash user directory inside the staging directory. So these are MapReduce specific directories. One, where it will store the intermediate data. Second, it will store some information about the job. First location is certainly not HDFS, that is the local directory, but second one is HDFS. So if you look at it, so the second directory slash user is the local directory, no, HDFS directory. The first one is local directory and second is HDFS directory. All right. Now it's time for us to create the directories that we had committed. All right, before I go ahead, can I explain you the use of staging conf directory? See, when a MapReduce job runs, okay, it has certain intermediate processing data, okay, and it's few locations where it writes some intermediate data while processing. It writes it in where lib hdfs cache mapred staging directory, and you want to have a history of what all jobs have run. All that is stored by username inside the hdfs directory. So what you're saying is, I want to write that particular data in staging's user directory. So basically all your job history is stored in that particular thing along with some intermediate processings basically. So tell me one thing. Now we've committed to certain directories, let's create them. So what we say is, we say sudo mkdir p disk 1 dfs disk 2 nn disk 1 data node disk 1 mapred local. All right, the directories are created. Let's create them on both the other machines also. Same thing here. So directories are getting created. All right. Now the directories are created, and these directories are for HDFS to store its own data. Okay. That's why we need to give permissions to HDFS and MapReduce on these directories. Okay. So our goal is to now give permissions to these guys. What we do is we say sudo chown -r HDFS Hadoop home disk 1. Then I say for mapred directories, the owner should be mapred. All done. Ownerships are now given to everyone. This all I'm doing is just creating those directories which are required and giving the permission, nothing else. No rocket science here. All right. Same thing. Okay, I've done a mistake here. It should be mapred local. Thank God. Else we would have got a permission issue. Okay. And here the same thing. So all the committed directories are created. Let's pause here for a minute and let's see all the questions that have come. So the question is, what is mkdir-p? When you say -p, that means if the parent directory is not existing, please create that also. That's it. What does HDFS Hadoop means? So I guess we've discussed. Okay, I'm not sure. Okay, so when you install Hadoop, it creates two users, HDFS and MapReduce, and it creates one group called Hadoop. So in this command, what I'm trying to say is, please give ownership of this folder to a user called HDFS who belongs to a group called Hadoop. All right. So now all the directories that we committed are created right now. Now all the required directories and stuff is there. All we need to do now is start necessary processes. See the cluster. All right, guys. So we've created everything. Now we will just start name node on the name node machine, data node on the data node machine, and we will see everything working together. So now we've basically created all the directories that we had committed to. Now it's time to set up the cluster. What you do is you just a minute, I'm opening the PDF. Now we are setting up the cluster and we will format the name node. So what I do is I say sudo new hdfs Hadoop name node format. So the name node is formatted now. All done. On the name node, I will start name node and secondary name node. That is etc initd Hadoop hdfs name node start. Yes, we will format name node only on the name node because only that there is only one master, right? So we'll format the master. Okay, I'll tell you what exactly heap size is. See, this heap size command is for our what you call classroom setup where we do a multi-node setup on virtual machines where RAM is very less. Okay, so I'm not doing it here because I have full RAM. I don't have to worry about setting the heap size less than, let's say, 200 or something. We will do RAID, and we are actually doing RAID here that we are writing name node data to 2 disks, correct? Now, in real world, you'll write it to 2 volumes. To simulate that, I'm writing to 2 different folders. That's it. So I'm already backing it up. Now, our name node and secondary name node is up and running. Let's verify that. So we have this Java process status tool that tells us that name node is up and running and secondary node is up and running. We are all good. But we haven't verified if data node is able to talk to name node on port 8020. Right? We have to open the ports. We haven't opened the ports so far. Say yum install. Let's do a telnet and see. So now let's see if we are able to telnet to the name node. That is important. So I say telnet name node 22. 22 will work. That means port 22 is open. Now let's see if I'm able to do that for port 8020 because that is my. So you see port 8020 is not open. That's a problem. Now if port 8020 is not open, you will have to talk to your network guy and open it. So what we'll do is we'll simply go ahead and say for now let's be liberal and say okay, open all the TCP. All right. So let's say you do All right, so yeah, it's already existing. So all TCP is open. But having said that, you will still not be able to do it because the reason is this. If you look at ps-ef grep 8020, what you see is that this particular thing has opened on this particular port. Along with that, it should have ideally been 0000. Now just a workaround. Now my this machine is not able to reach. Okay, what we will do is, for right now we will just disable the firewall. Okay, again this is a networking concept. We will just disable the firewall on Linux boxes so that they are able to talk to each other. In real world, your network guy will take care of the firewall. I am just disabling it for now. So I say service IP tables save stop. Chk config IP tables off. I am just disabling the firewall, but it's not a good idea in real world. Real world, you'll have to find a way to do it. Basically, not find a way to do it. It's straightforward. Your administrator on the network side will open the ports. It's no rocket science. All done. Now let's see if I'm able to do a telnet. Still not able to do it. Oops. Now it's tricky. I have turned off the firewall also. Tables off. Service IP table stop. Save. This is strange because it works wonders. One minute. This is crazy. Works. This is amazingly crazy. When everything is shut down on the firewall, now does everyone belong to 2012 group? Let me just check. What is that I'm missing? It's 2012. Yeah, they all belong to the very same security group. This one. I just don't recall. What else could be it? Okay, this works. Data node 2 works. Wow, isn't that strange? Okay, even this works. I guess I was doing something wrong. What's, or maybe I just shut it down before. So anyways, so this works. 80/20, and this works. All right. So we have everybody pointing to the, and again this is a networking concept, so just relax out. It will be done on the firewall level on in your what you call company. Now my name node and secondary name node is up. Now I will bring up the data node. So what I do is, I start the data node. Just a minute, it's so I say etc initd Hadoop HDFS data node start. I say etc initd Hadoop DFS data node start. So what I do is I run the same command. So now data node is started, and let's see where it points to. We'll see that. So I say so you see data node is started. You say data node is started. And here also you see data node has started. All right. All right. Just a minute. Data node is started. Now, if you see on my master node, my name node and secondary name node is up. On my slave node, my data node is up. Are you clear with this fact? Great. Now let's see how HDFS would respond. Say Hadoop fs, I'll create a directory, sudo u hdfs Hadoop fs mkdir tm. So I've created a directory called temp, and I will do chmod 1777. So I have run two commands on HDFS. Now let me show it from the cluster. I say Hadoop fs ls, show me the contents of root, show me the contents of the HDFS. Do you see this created? It was created from some other client, but now it's returned to the common HDFS, basically the distributed file system. That's why you're able to see it from everywhere. Hadoop fs ls root. Our multi-node cluster is running now. Our multi-node, okay. Now let me create a file here. I say Hadoop fs mkdir user root sudo -u hdfs. Now I give ownership of root to myself. Now I put 3 files there. I'm putting 3 files from HDFS. I'm putting just 3 XMLs or 4 XMLs. Let me create another folder called input so that we alright. So what you see is created an input directory. Now I say Hadoop fs put 3 or 4 XML files, which I say so I am dumping 4 files from Linux file system to Hadoop file system. What you see here is do you guys see the files? fs ls input. It's a distributed file system and everybody can see that. Hadoop fs is a prefix to every command that you're running on Hadoop file system. You are creating a directory on a distributed file system. That means everybody can see everything. Okay, it's a distributed file system. Let me just show it to you. Hadoop fs mkdir test directory from data node. Hadoop fs ls. Do you see that? It's a distributed file system. So now you can safely say your HDFS or your multi-node setup is 100% ready and raring to go. Now let's get to the MapReduce part. Now in a multi-node cluster, we've already created temp, we've created our root directory, we've created input directory also. Now it's time for us to create a MapReduce directory, that's a system directory for us to run our program. What we do is we say Hadoop fs sudo hdfs Hadoop fs mkdir mapred system. We give the ownership of that directory to mapred user. So we say ch own mapred Hadoop. So mapred owns this particular directory. All right, all done. Now it's time for us to run a MapReduce program. So now we are all set to run our program. Let's do it. Say Hadoop jar user lib Hadoop examples input grep input output. Wait, we've not started job tracker and task tracker. We've not started job tracker and task tracker. Let's start. etc NITD Hadoop start. So I've started job tracker on the master. So what you see is name node, secondary name node, job tracker on the master. Here we will start the task tracker. All right. If I do a JPS, what you see is data node and task tracker is up here. If I do a JPS here, I see data node and task tracker is up here. Now our mapreduce is also started. Now it's time to really do the, what we say is we say Hadoop jar user lib Hadoop 0.20 Hadoop examples dot jar grep input output dfs z dot plus. So for guys who have already done the first hands-on, you guys easily. So now I am running the job. It's a multi-node setup and I'm running this job. I hope it runs. No, it doesn't. It says there are some issues. Let's see what. It says user root has no permissions to write on the temp directory. My mistake. Because when I was doing chmod on temp, I should have done -r. I did not give recursive permission. Oops. Now I'm running this here. Started. All right, job is done. I can verify from here also. If I see output, say Hadoop fs cat output. Got it? So in this case, there are only 4 variables which are having DFS.
So this brings us to the end of the session. So if you have any doubts or any queries, do comment below. We'd love to help you out. So thank you and happy learning.